Rolle's theorem states, let f be a function that is continuous on the closed interval, ab, and differentiable on the open interval, ab. If f of a is equal to f of b, then there exists at least one number c in that open interval, ab, such that f prime of c equals 0. This may sound really familiar because it is a special case of the mean value theorem. To see a video on the mean value theorem, click here. Let's take a look at what this would look like on a graph. So we have some interval, a, b, and some function f. Now it does say that f of a is equal to f of b. So to help me when I draw this graph, I know that there is some point here, and it's at the same y value as this point over here. So I'm just going to draw some random function, but I know that those points exist there. And here is my function f. As you can see, f is continuous on that closed interval ab, and also differentiable. It's nice, smooth, and continuous, and doesn't have any sharp turns or discontinuities. As long as f of a is equal to f of b, and these two conditions are met, that means there has to be at least one number c somewhere in ab. So at least one number c in AB such that the slope of the tangent line at that c value, so for example, this tangent line right here would have to be 0. Let's take a look at an example. Given f of x equals x squared plus 3x minus 5, find the value c that is guaranteed by Rolle's theorem on the interval -4, 1. Our function f of x is a quadratic function. It's a polynomial function. That automatically means it's going to be nice and smooth and continuous on this interval. So we have made sure the first two conditions are met. Now let's make sure f of a is equal to f of b by plugging in -4 and 1 into our function f of x. So if we find f of -4, we would have -4 squared plus 3 times -4 minus 5. Doing some mental math here, we would have 16 minus 12, which is 4, minus 5, which is -1. And you can actually see that on the graph that I put in over here. At an x value of -4, the function value is -1. Now let's find f of 1. We can plug in 1 into our function f of x, and we can see we have 1 plus 3, which is 4, minus 5, which is also -1. As you can see, f of a is equal to f of b. That means there must be one number c, some number c between -4 and 1, such that the instantaneous rate of change, the slope of the tangent line, is equal to 0. So let's find the derivative. If we find f prime of x, we would have 2x plus 3. Well, simply substituting in c for x, we would see that we have 2c plus 3. Now, if we set that derivative, slope of the tangent line, equal to 0, we'll be able to find our c value. So that is when 2c plus 3 is equal to 0, or when c is -3/2. We know that -3/2 is the same thing as -1.5. So let's go to the graph and take a look at an x value of -1.5, follow the graph down to right here, and sure enough, we can see that at -3/2, the slope of the tangent line is in fact equal to 0. And that's Rolle's theorem. If you found this video useful, make sure to click subscribe right now so that you're informed when new videos come out to help you in your calculus class.